Good morning, ladies and gentlemen. As you can see, we are going to have ourselves a very interesting time today. All right, as you can see on the board, you have a matching exercise to complete today. Now, you're asking, Mr. Hale, where is this activity at? Where am I going to find this in my book? This is Module 4. So these are the very first pages in the second half of your book. So Module 4, Lesson 1 is where we're at. Now, I'm going to give you all a few minutes, and when I say few minutes, I'm actually going to just sit here and let silence ring as I let my watch count down for me. So I'm going to give you all about 4 minutes to match as many of these you can, and then we will come back to it and discuss. You have 3 minutes remaining. You have 2 minutes remaining. At this point, I expect some of you are probably stuck. You're not sure where to go, what to do, what to expect. So think of it like this. We're working on percents. So the percentages in the left side are going to match these questions on the right side. Now, I need you to think about this, okay? Looking at each question, it gives you information. I'm half of a half. That's 1/4. How do you say that, Mr. Hale? How's that 1/4? Well, think about it. Half of a half. Well, 1/2 is 50 cents. What's half of 50 cents? A quarter, or 25 cents, which would be 25%, or 1/4. Ooh, Mr. Hale just gave me an answer. Yes, I did. The question is, though, is how many of y'all actually caught it? And continue looking at the very first line. It gives you some information. I'm equal to 1. I am more than 1. I am 1/10 of a tenth. I am less than 1/4 but more than 100th. There are teeny tiny clues mixed in each one of these. You need to identify those clues. You've got 1 minute remaining. And time. All right, so let's see how well you did. First question, I am half of a half. Well, it's like I said, a half of a half means 1/2 times 1/2. That doesn't come out looking very good, does it? Well, a half of a half means it's 1/4. Okay? 1/4 is 25 cents out of a dollar, or it's 25%. All right? And I'm going for the quick ones. I am equal to 1. 35 questions out of 35 questions were answered correctly. If I gave you a test and you got 35 out of 35, what was your grade? A 100. So obviously 35 questions out of 35 questions would have been 100%. Let's see. I am more than 1. I am more than 1. So let's see. If 1 is 100%, then anything greater than 1 has to be greater than 100%. So my list only contains 25, 50, 30, 1, 10, 1/2%. Those are all less than 1. There's only one option left that is greater than 1, 300%. Let's see here. Let's try to make this a little smaller so we can actually write. So this was 25%. This one was 100%. This one here is 300%. Let's see. I am less than 100th. 25 out of 5,000 contestants won a prize. Let's come back to that one. I am the chance of birthing a boy or a girl. Flip a coin and it will land on heads or tails. The second sentence gives this one away. If you flip a coin, what's the chance of, what do they normally say? You got a chance of a 50-50. 50% chance of landing on heads, a 50% chance of landing on tails. So I am the chance of birthing a boy or a girl is going to be 50%. Okay, so that's got to be this one. I'm less than a half but more than a fourth. Okay, so 1/4 to 1/2. It's got to be somewhere in between these two. Okay, so less than a half or greater than a fourth. So that means it's got to be, let's change these to percents. It's got to be somewhere between 25 and 50%. So that leaves me only 30% remaining. 15 out of 50 play drums. That would be 30%. Okay, so now we got 30% here. See, now we're starting to reduce our options. Okay, I am 1/10 of a tenth. 1 penny is this part of a dollar. How many cents is 1 penny? 1. 1 cent out of how many cents in a dollar? 100. So this is 1 out of 100, or this is going to be 1%. So we got two answers left, 0.5% and 10%. These are the last two. Okay, I am less than a fourth but more than 100th. So I am greater than 1%, but I'm less than 25%. Okay, that leaves only one possible answer. That's got to be 10%, which means the one that we're missing, I am less than 100 or 100th, 25 out of 5,000 contestants won the prize. That would be 0.5%. Now, I know what you're thinking. Mr. Hale, how did you know all these? How is it that you were able to identify what the percents were without doing any mathematical work? Okay, the sentences were the clues. This is just a common sense activity. Nobody expects you to know percent. Not right now. Not at least as well as I would do it. And what I said, my wife makes me go grocery shopping and go clothes shopping with her because I'm good at percents. Okay, this is instantaneous. These are easy things. You look for key words. Like in this problem here, I looked at more than 1. I'm equal to 1. Okay, less than a half, more than a fourth. There's key words in each of these phrases. All right, so look at your answers. Make sure you matched them up correctly. Erase what you need to erase and go back and get them right. All right, so color in the grids to represent the following fractions. Well, let's make sure of something here. We got 3 grids here. Let's make sure we're actually looking at grids here of 100. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so that's a grid of a 10 by 10. So if I asked you what the area of that rectangle would be, you would tell me that the area is length times width, which would be 10 times 10, or 100 squares. So that's 100 squares. Now, if this is the total number of squares, then this is the number of squares I'm going to shade. Okay, so I'm going to shade in 30 squares. Well, I know this first row, the second row, and third row all have 10. So that's 10, that's 20, and this is going to be 30. So look at the next problem. 3 out of 100. How many squares should I shade 3 out of 100? 3 out of 100. Well, I know each row has 10, but I'm only looking at shading 3. I could shade in 3 like this. That's 3. Or if you wanted to be super special about it, you could shade in 1, 2, 3. That's still 3 out of 100. Okay? However you shade it is entirely up to you. Just remember, all you're doing is shading in 3 blocks. All right? 1/3 out of 100. Whoa, this is a good one. I like 1/3 out of 100. So let's think about this. If this said 1 out of 100, how many blocks would I shade in? I would shade in 1. But is it saying 1 out of 100? No. It's saying 1/3 out of 100. So that means I'm taking 1/3 of 1 block, and I'm shading it in. So there's 1/3 out of 100. Okay? 1/3 out of 100 is now shaded. This is all what we talk about as percents. Percent, the key word, percent. About it. There are 100 cents in a dollar. There are 100 years in a century. Okay? 100 is the key word. There are 100 centimeters in a meter. So there's 100 centimeters in a meter. Cent, 100. Always think about that. Cent is going to be 100. So if we see the word percent, it means out of 100. So this would be 30%. 3 out of 100 would be 3%. 1/3 out of 100 would be 1/3%. All right, use the definition of the word percent to write each percent as a fraction and then as a decimal. As I said, okay, percent means out of 100. Oop, not 1,000, 100. See, I got ahead of myself. So this is 37.5%, or 37.5 out of 100. There's your fraction. Now, if I was to write 37.5% as a decimal, all I'd write is 37.5. So I'd write 37.5, but then I would move the decimal right here. Because think about it. I'm taking 37.5 and dividing it by 100. Okay? 100%. That's 100 out of 100. What's 100 out of 100? 1. Okay? 110% out of 100. Okay? 110%. 110 out of 100. Now, if you plugged in 110 into a calculator, 110 divided by 100, you would get 1.1, or 1 1/10. All right, 1%. That is 1 out of 100. Percent, think about it. Percent out of 100. 1% is 1 out of 100. If I take 1 and divide it by 100, I get 0.01. That's 100th. All right, 100th. 0.5% is half out of 100. If I took 1/2 and divided it by 100, I would get 0.05. I'd get 5 thousandths. You're going to need to know how to do this without a calculator. All right, I'm not saying this is life or death, but converting percents to fractions and then fractions to decimals should be instantaneous without a calculator. You're not always going to have your phone on you. Your phone may end up dying on you. And you need to find out whether or not you're getting ripped off for work on your car. Whether or not you're getting a good deal with a 10% off versus a 20% off coupon. You need to know what's the bargain. You need to know this by knowing how to convert percentages to fractions, fractions to decimals. All right, so fill in the chart by converting these between fractions, decimals, and percents. Show your work in the space below. Okay, so we've got 350%. Now we're blessed here. 350% is easy. It's 350 out of 100. Okay, 350 out of 100. Now, if I took 350 and I divided it by 100, I would get 3 5/10. Easy enough. But what about the next one, Mr. Hale? 0 25 thousandths. Okay. So 0 25 thousandths. Well, let's write it as it says. 25 thousandths. Well, a percent is out of 100. Of 100 instead. Right. I can divide these both by 10. So 1,000 divided by 10 is 100. 2.5 divided by, or 25 divided by 10 is 2.5%. And we just wrote this as a fraction, 25 thousandths or 2.5 100ths. Okay, what about the fraction? How do we convert the fraction? We do division. For a fraction to go to a decimal, we're going to do 1 divided by 8. Mr. Hale, why aren't we doing 8 divided by 1? Well, the goal here is actually to convert to a decimal. We know 1/8 is less than 1, so the value's got to be less than 1. If I do 1 divided by, or if I do 8 divided by 1, then the answer is 8. That doesn't do me any good. 8's greater than 1/8. That's not the right answer. So we're going to do 1 divided by 8. You read it as you go. You start from the top and read it down. 1 divided by 8. 8 can't go into 1, so we got a 0. We tack on a decimal, put on a 0. 8 can go into 10 one time. Before we forget, let's make sure we shift this decimal up to the top. 1 times 8 is 8. Subtract, we get 2. 10 minus 8 is 2. Well, 2 is less than 8, so we're good. So we add another 0, shoot it down. 8 goes into 20 2 times. That's 16. Subtract, we get 4. Add another 0, bring it down. 0's down here. Oh, my bad, guys. You guys don't see that. So we're going to shoot this back up over here. All right, so 20 minus 16 is 4. We add a 0. 8 goes into 40 how many times? 5. 5 times 8 is 40. 40 minus 40 is going to be 0. So we're done. So there's our decimal. 0 and 125 thousandths. How do I write that as a percent? Oh, that's interesting. Well, again, let's write this as a fraction. 125 thousandths. I can convert the fraction to 100 by dividing by 10. So what's 125 divided by 10? 12.5%. There's your percentages. This is going to take practice. You're going to have practice on this tonight. You will have something to do for homework. You also have a test to finish come Wednesday. Do not waste your opportunity. I'm not going to check your homework until Thursday. So you're going to get 2 days to finish this. Do not waste it. Please, by all means, do not waste it. All right. Now, we've left Lesson 1. We're in Lesson 2. Lesson 2. Lesson 2, we're looking at the part, the whole, and the percentages. So that means we need to identify parts, we need to identify wholes, and we need to identify percentages. Okay? So what is the whole unit in each scenario? Okay? Well, that's actually not such a hard problem to answer. What is the whole unit in each scenario? We need to know what the whole is. Now, normally, the whole is easy to identify. The whole is always going to be the larger number. If the percentage is less than 100, then it's always going to be the larger number is going to be your whole. Okay, so 15 is what percent of 90? Okay, if I wrote this as an equation, it would be 15 equals 90 times x. Which one do you think is the whole? 15 or 90? Okay, it would be 90. 90 is the whole unit. What about the next one? What number is 10% of 56? Okay, we don't know. Well, this one here we do know. It's 56. Okay, 90% is 90% of a number is 180. Okay, we don't know the whole. We don't. Because we know that this is 0.90 times x equals 180. We know the percent, we know the part, but we don't know the whole. So in this case here, I'm going to say the whole is x. We don't know that. It's an unknown. And the fourth one, we got a bag of candy contains 300 pieces, and 25% of the pieces in the bag are red. What's the whole? The number of pieces that are red in the bag, or the 300 total pieces that are in the bag? The 300 total pieces that are in the bag. All right, 70% of the students earned a B on the test. Okay, what would be identified as the whole? Would it be the number of students that got a B on the test, or would it be the total number of students in the classroom? Right, it would be the total number of students in the classroom. Okay, that's what would be the whole. Okay, so the total number of students. What about the last one? The 20 girls in the class represented 55% of the students in the classroom. So the 20 girls is only 55% of the students in the classroom. So is 20 girls going to be the whole, or is it going to be the total number of kids in the classroom? Right, the total number of students. Just because we say identify the part, the whole unit, sorry, not the part, the whole unit, does not mean that we're always going to know what the number is. You can see right there, out of 6 problems, 3 of them, we had no clue what the actual number was. It's an unknown to us. But yet we could probably solve this and actually find the answer. So it's patience. Patience is the key here. Okay? All right, let's continue on. So read each problem, complete the table to record what you know. 40% of the students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? Okay, now this is easy. We're trying to identify the part, the percent, and the whole. Well, the percent's always going to be easy to find because it's going to have this little symbol on it. This is going to be percent. So when we find that, then we know what the percent is. So in this case, 40% is the students, or 40% is the percent. Now we need to identify the part and the whole. Okay? So these are going to be numbers. We're looking for numbers for the part and the whole. Now there is only one more number left in this thing, 20 students. Okay? So if there are 20 students on the field trip, how many love the museum? So how many students are on the field trip? You're right. There's 20 students on the field trip. Okay? So what we don't know is the number that love the museum. All right, next problem. 40% of the students on the field trip love the museum. If 20 students love the museum, how many are on the field trip? So again, we identify the quick stuff. Here's 40%. We know that, 40%. Now this problem sounds a lot like the first one. First one said if there are 20 students on the field trip, how many love the museum? This one told us that there were 20 students on the field trip. The second problem is saying, though, if 20 students love the museum, how many are on the field trip? See, we know now that this is reverse of this one here, because this one's asking how many are on the field trip. That's the number that's the whole. Number on the field trip. So that means the remaining number has got to be the part. So that would be 20 students. Now, if 20 students on the field trip love the museum, if there are 40 students on the field trip, what percent love the museum? Okay, so how many students are on the field trip? 40. 40 students are on the field trip. 20 students love the field trip. 20 students on the field trip love the museum. And then it says, what percent? So do we know the percent? No, we don't. So that's what we're looking for. Percent that love the museum. So that means what we do know is the part and the whole. So now we got to identify what's the part and what's the whole. Now remember what I said. If the percent is less than 100, the larger number tends to be the whole. So in this case here, there are 40 students on the field trip. 40 students is the whole, which means 20 students is the part. All right? Again, you've got to read these questions. Read them carefully. Look at what the information is. Nobody's sitting here saying you're going to find the answer immediately. Nobody's going to be like, ooh, Mr. Hale, I know what the part is. I know what the whole is. Mr. Hale, I know the percent. Okay, yeah, the percent's the easiest. If you can identify the percent, then congratulations. You're awesome. You're fantastic. Okay? But if you can identify the part and the whole, then you're phenomenal. Because this is where a lot of your peers mess up at. Identifying the percent's easy because you're looking for the number that has the percent sign. But identifying the part and the whole, that's where things get a little crazy. Okay? That's what we need to work on is what's the percent and what's the whole. Or, I'm sorry, what's the part and what's the whole, not the percent. My bad. Okay, moving on to slide 7. All right, so visual approaches defining part given the percent of the whole. Okay, so this is the visual approaches. When we talk about visual approaches, we're talking about tape diagrams and double number lines. I like a tape diagram. Tape diagrams are easy. They're easy visual representations. Okay, so 20% of the students earned an A on the class. If there were 30 students in the class, how many got an A? Okay, 20%. Now, if you look at the board, I've got it broken up into 5. You're asking, Mr. Hale, why are you doing 5? Well, it says 20%, right? 20%, so 20 out of 100. Well, what is 20 and 100? What can they both be divided by? Because I can reduce this. Okay, well, right, they can be divided by 10. Okay, so 20 divided by 10 is 2. 100 divided by 10 is 10. Is 2/10 the final answer? No, it's not. 2/10 can also be divided by what? Right, they can be divided by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. Hence where I got my 5 parts. Okay, we're looking at 1/5. This is the number of students, okay, with an A. This is everybody else in the class. But this, the 5 parts, is the whole. So how many students are in the class? There's 30. 30 students. Okay, is that the whole of the part? You're right, that's the whole. So the whole thing represents 30 students. But then I've got 5 individual parts. How do I find out how many students had an A? Oh, I can divide by 5. Well, 30 divided by 5, 30 divided by 5. 30 divided by 5. What number can I multiply by 5 to get 30? Oh, I get 6. So that means each block represents 6 students. So how many students got an A? 6 students got an A. So 6 students is our answer. So let's erase this real quick. Well, let's try it again. Okay, so our answer is 6 students. 6 students got an A. That's a visual approach. Okay, let's move on. So exercise 1. In Ty's art class, 12% of the Flag Day art projects received a perfect score. There were 25 art projects turned in by Ty's class. How many of the art projects earned a perfect score? Okay, so let's identify a few things here. Let's identify the part, the percent, and the whole. Okay? Well, what's the percent? Okay, we got lucky. That's 12. 12%. Okay, what's the whole? Okay, 25 art projects. So what we're looking for is the part. We don't know the part. Okay? Now, it says a visual representation. Okay? Now, this is where things get a little crazy for me, okay? So 12% is 12 out of 100, right? What's 12 out of 100 reduced to? Well, we can divide by 2, so that would be 6/50ths. Can I divide that again? You're right. I can get 3/25ths. So 3 out of every 25 got an A. 3 out of every 25 got an A? Or I've got a perfect score? Well, is it just me, or does that look like we came up with the answer? It said there were 25 art projects, right? Well, that says 3 out of 25. So if there are 25 art projects in the room, how many got a perfect score? 3. Sometimes you can come across the answer without even realizing that you came across the answer. 3 received a perfect score. There's your visualization. Sometimes you don't need a number line. Sometimes you don't need a double number line or a tape diagram. You can find it instantaneously. This is a wonderful way. This is a wonderful thing to see. I actually am happy that we actually get to see this. All right, let's move on to number 9. I know it's a lot of slides, but technically the last slide's your homework, so we got 9, 10, and 11 left. So example 2, a numeric approach to finding a part given a percent of the whole. All right, so a numeric approach, this is actually one of my favorite ways of finding percentages, okay, because this requires just a little bit of multiplication and division. All right, now I'll show you how all this works. So in Ty's English class, 70% of the students completed an essay by the due date. Okay, there are 30 students in Ty's English class. How many completed the essay by the due date? So again, we need to identify our part, our percent, and our whole. Okay, well, our percent is 70%. Our whole is the number of students in Ty's English class, which is 30. So what we don't know is the part. Okay, so this is what I like to do. Okay. So let's break this down. We got percent in this column. We got whole in this column. Okay, so these are our two columns, percent and whole. Okay, so how many students are in the classroom? 30. Now, if 30 students had completed the essay by the due date, what would the percent be? Right, okay, so 30 students out of 30 students would be 100%. Okay, now this is where a little bit of division and multiplication comes in at. Okay, so 70%, that's a little hard to get to, right? I can't just start subtracting anything. That doesn't make sense. But I can start doing some manipulation. I can start manipulating this a little bit, starting to get closer and closer and closer. Now I'm thinking of 70%. 70. That's 2 times 35. Well, that doesn't really help me out here. Let's see. 5 times 14, well, that really doesn't help me out either. 7 times 10. 7 times 10. I like that. 7 times 10 is actually a good problem to work with. Okay, now you're asking me, why are we saying 7 times 10? Well, because we're going to move to 10%. Okay? To go from 100% to 10%, normally you're going to say you're going to subtract 90. But in this problem, we're looking at multiplication and division. What number did I divide 100 by to get to 10? You're right. I divided by 10. So what's 30 divided by 10? 3. So 10% of 30 is 3. 10% of 30 equals 3. Okay? But what we're looking for is 70%. So 70%. To go from 10% to 70%, what did I do? Right, I multiplied by 7. So what's 3 times 7 going to be? 21. So how many students completed the essay on time? 21. 21 students completed the essay on time. So congratulations, you just found the answer. And you're like, Mr. Hale, wait a minute. I've never learned how to do percents that way. Why are you showing me how to do percents that way? Because in the real world, that's actually the fastest way to find your answer. So think of it like this, okay? My wife wants to know what 40% off something is, okay? So I'm thinking to myself, okay, what's 40%? She's found an item that's $200. What's 40% of $200? Okay, well, I don't know 40% of 200 right at the top of my head, but I know 10% of 200 is 20. Well, to go from 10% to 40% is just multiplying by 4. So 20 times 4 is 80. So I know 40% of $200 is $80 off. So she's going to get that jacket for $120. Okay? This is the fastest way to find a percentage, in my opinion. Because if you can take any percent and manipulate it with a 10% in it, things get so much easier to work with. All right? Moving on. All right, so a bag of candy contains 300 pieces, of which 28% are red. How many pieces are red? Well, let's start off with the easy problem. Which quantity represents the whole? So is it the number of pieces that are red? Is it the 28%? Or is it the 300 pieces of candy? Right, the 300 pieces of candy. That's the quantity that represents the whole. 300. All right, I know you're probably sick and tired of seeing the neon green, so let's go to something a little bit more dark. Okay, so which of the terms in the percent equation is unknown? Okay, so what's unknown? Is it the whole, the percent, or the part? It's the part. We don't know the part. So we're going to represent, so we got the part. We don't know the part. So what letter are we going to represent part with? Well, you know what? I like P. All right, so we're going to represent the part with P. Okay, so the next thing we're going to do is write an expression using the percent and the whole to represent the number of pieces of candy. Okay, write an expression using the percent and the whole. Percent and the whole. Let's see. I remember the whole was 300. The percent was 28%. So 28% of 300 is going to be my answer. But how do I write that as an expression? Well, in math, the word of means to multiply. The word is means equal. Okay? So they've given us everything we need. Because what they said was 28% of 300 is what? Or, yeah, they didn't say what. They actually said is red candy. Is red candy. So that's a written expression. How do I verbalize that? Well, I changed some things. The word of means multiplication. The word is means equals. And what I don't know is the red candy or the part, which is P. So 28% of 300 equals P. Now, that's an equation. So it's that expression. So technically, we wouldn't even have the P. It equals P. So our expression would be 28% of 300. Now it says write and solve an equation to find the unknown quantity. Okay? So this is where we get to write our equation. Now, I don't like to, when we do equations, we can't leave 28%. So we got to rewrite it. Do we want fractions or decimals? Well, let's write both. 28% is the same as 28 out of 100 or 0 and 28 hundredths. Those are your two options, okay? So my equation is, and in this case here, I like the 28 hundredths. So 28 hundredths times 300 is P. Okay? Now you're sitting here thinking, Mr. Hale, how are we going to do this? Okay, well, let's rewrite it. P equals 28 times 300 divided by 1 times 100. Now, Mr. Hale, why did you write it like that? Well, I wrote it like that because I noticed the 300 and the 100 have something in common. They both have 2 zeros. So I'm thinking to myself, that's pretty easy to divide with. So 300 divided by 100 is simply nothing more than just 3. So I'm looking at an answer of P equals 28 times 3, which means P equals, let's see, 28 times 3, that should be 84, I believe. So 84 are red candies. And there's your answer. 84 are red candies. Interesting, huh? You're going to be working on that too. All right, so I'm going to leave that there for a second, give you an opportunity to catch it. All right. And to make it easy, I'm going to do the Jeopardy theme song. Do 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 doom 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 boom. Congratulations! It's the end. It's time to go to the last slide. Exercise 2. So a bag of candies contains 300 pieces, of which 28% are red. How many pieces are not red? Huh, that's interesting. Is that not the same problem from the last one? It's not? What do you mean? Oh, this one says not red. Oh, I didn't see that. That's interesting. So this one says not red. Well, I remember 28% are red. So what percentage are not red? Well, remember, percents out of 100. So 2% have to add up to equal 100. Has to equal whole. So if 28% are red, that means 72% are not red. So let's come over here. So this is 72%. So 72% of the 300 are not red. So that means we can find an equation. So 72%, if you remember, is 72 out of 100, or it's 0 and 72 hundredths. Okay. So now my equation. Okay. 72 hundredths times 300 equals n, because it says that are not red. And you're like, Mr. Hale, how'd you come up with the equation? Because the equation is the same as the previous problem. The only difference is, instead of using 28%, we're using 72%. So instead of using 28 out of 100, we're going to use 72 out of 100. Equation hasn't changed. So now it says use your equation to find the number of pieces of candy that are not red. Okay. So n equals 72 out of 100 times 300 over 1. Same thing again. 300 divided by 100. Those two zeros will cancel out, so would that one there. So we're looking at n equals 72 times 3. Well, 72 times 3 is going to be n equals 216 are not red. So 216 of the candies are not red. Does that relate back to what we had on the previous slide? Well, let's take a look at something real quick. Okay, let's go back a little. So we said the answer was, let's scroll down. We said 84 were red candies. So if this is 84, the next number we found on the next slide should add up to 300 if we're right. So let's check. All right, so we got 216 that are red, and then I had 84 that were red. 216 plus 84 is 300. It checks. We're good. We're golden. Okay? Oh, wait a minute. We got one more problem. Jaleel told his math teacher that he could use the answer from example 3 in mental math to find the number of pieces of candy that are not red. Explain what Jaleel meant by that. Okay. So Jaleel wants to use mental math. Well, the previous problem said that 28% of the bag of candy was red. Okay? So if out of 300 pieces there were 84 that were red, would it not make sense that whatever's left out of the 300 would not be red, correct? So what Jaleel's saying is he could have just taken 300, subtracted 84, and found out that 216 are not red. We didn't have to go through all this according to Jaleel. And he's right. We could have used mental math to find this answer. But the point of this activity is not to use just mental math. It's to set up equations. Know how to use an equation, how to set up an equation to solve for percents. Because sometimes you're not going to have two questions that are back-to-back. that are going to sit there and ask you to use mental math like this. All right? Last but not least, one more slide. Congratulations, you got homework. Woohoo! Remember what I said. You got 2 days. Because when you come back tomorrow, you're going to be finishing your test. So obviously I'm not going to check your homework that day. We're going to check your homework on Thursday, or no, Wednesday. No, Wednesday's the test day. Thursday I'm going to check your homework. So this is your lessons. So in Module 4, Lesson 1, I want you to do numbers 1, 2, and 4. In Lesson 2, I want you to do numbers 1, 2, 5, 6, and 9. Okay? Now, if you did not get to this point, and I'm serious about this, if you did not get to this point, you need to make sure. I got it. Never mind. How about this? To ensure that I know if you got to this point or not, on your test, I will give you 15 bonus points. Yes, 15. That equates to 150 bonus points on your test, since we're talking big numbers here, okay? If you sit there and tell me that the Philadelphia Eagles won the Super Bowl, right at the bottom of your test, the very last page, somewhere along the side or something like that, I will give you 15% credit on your test. That's 15% of your test you'll get bonus points for. So that's 15 extra points out of 100. So you could potentially earn a 115 if you get all the questions right. If you get an 85, then you get 15 points, you get 100. Okay? So again, if you get to this point, then you should know that on the side of your test, it should say, Philadelphia Eagles won the Super Bowl. Okay? I will give you 5 more bonus points if you correctly give me the score. And I'm not telling you that. So potentially 20 bonus points if you can tell me, if you write on the side, the Philadelphia Eagles won the Super Bowl, and then tell me the score. All right? Y'all have yourselves a good one. I will look forward to seeing your tests tomorrow. Hopefully some of y'all will have gotten to this point. All right? And that's the end of it, guys.